Hey guys, it's CodeSagan here, and in this video I'm going to be explaining how to program your Spike Prime robot using Python. So Python is a very powerful language. It's used in many different aspects of programming, and we're going to be using it to program our robot. So definitely, if you haven't got any other programming experience and this is your first time trying to program a robot, definitely try and use word blocks first. I've got a video up that explains basic movements using blocks and Scratch. However, if you're a little bit more experienced, maybe you've done robotics before or you have some programming knowledge, definitely learning Python is a very powerful skill, and it's going to help you a lot, not only for now, but also in your future. It's a really good tool to introduce you to real life programming. So something that a lot of people have a misconception about is what programming is. Programming is simply a set of instructions. So a lot of people think programming is, hacking, going onto a laptop, big screens, dual monitors, a lot of programming. A lot of lines of code, sorry. This isn't what programming is, in general. Simply put, programming is a set of instructions. So we're going to be putting up lines of instructions, and the robot is going to follow those lines and it will know what it needs to do. So this robot, if you want it to go straight, we'll put a command in and it'll go straight. In the next line, if you want it to turn, we're going to drop down a line and put our command to turn. This line by line process is basically what Python is. It's also other programming languages like Java and C++, that kind of thing. They all follow this line by line process. And each of these lines is simply a set of instructions. So think about like a cookbook recipe for your robot. So without further ado, let's actually go into the programming side of things and learn how to code a robot using Python. So I've got my laptop up here. We'll switch over to Python, and we're going to we'll switch over to Spike, and we're going to create a new program. However, don't click word box, just click Python and create. So this will take some time. However, we essentially have our setup here. So as you can see, this is what the Python programming environment will look like. First things first, we have this knowledge base on the side. Now, I'll be referring to this every so often. However, I've got the commands already, in my head and written out. So, if you ever forget something, I've definitely explained it from here. Things like moving forwards, turning side to side. In fact, you could probably also, if you're interested, teach yourself how to program just with this knowledge base. It's very helpful and it's very important. However, I'm going to stick it to the side, and if you're watching this video, you probably won't need the knowledge base because you've just got my video to guide you through the process. So now that we put that to the side, let's further explain, some of the things we have up here. So first things first, the connect button. You may have already seen this. You can either connect your robot using the Bluetooth or using the Bluetooth feature or your wire. So I recommend using Bluetooth if you can. My robot's actually dead at the moment, so unfortunately we cannot. But simply connect your robot. You'll see all your ports, all your motors, all your sensors. We don't really need that to actually do programming though, so that's really good. We can just get started. In the bottom right here, we have our hub number. So whatever program we can, program up to infinite number of programs, I guess. I'm not sure what the limit is. I'm sure there's a programming limit, but it doesn't really matter. We're going to just stick to 0. No need for 10 programs. This is going to be our first program. If you want to start your robot, click this play button. Stop it, click the stop button. Pretty simple. You can also zoom out. I'm not sure why you'd want to do that, because with I guess if you have longer lines of programs, that's helpful. But it's line by line, so you can always just go side to side to figure out what you need to do. And you can also zoom to fit the page. That's a little bit too much for me. Let me zoom out a little bit. All right, perfect. And forwards and backs, Control Z, Command up Y, Control Command depending on if you're on Windows or Mac. Doesn't really matter. So I prefer to use the shortcuts as opposed to these little arrows here. So that's everything around the program environment. Let's actually talk about the environment itself. So as you can see, we have these first 3 lines. These 3 lines are extremely important, okay? They're automatic, they come up by themselves, and it's essentially the initialization for your program. So you can see there are a few things you may automatically see, like prime hub, light, buttons, force, sensors, motors, that kind of thing. This is essentially setting up our program. Do not mess with these 3 lines, just leave them. Let them be, don't touch them. Because this is what's going to allow us to program later. Lego are helpful enough to set up this for us, and it's going to be the same every time. So you can close the program, open up a new one. These 3 lines are going to be here. They're basically imports. So they import from libraries, and they learn, they'll give us the tools that we need to program our robot, but you don't need to worry about exactly what they are, because the main thing you need to worry about are the lines below. So we're going to start with number 5. If you put enter, you'll see that the numbers go down, and if you backspace, the numbers go up. The next thing you need to know is the difference, in the colors of your code. So if I type randomly, you'll see that, it comes up as black. However, if I type special words like if, or else even, these words come up as blue. These are, powerful words that basically allow us to use operators, that kind of thing. As you can see, within exclamation points, it's pink. That those are things like strings and words. However, the basic is that everything will come up as black, and then if something isn't black, it's kind of like a special word. Like, you can see import, from. These words, you don't need to worry about what they do yet. I'll explain them later. But these are just special words or operators. The next thing you need to know is comments. Comments are extremely important. So if you put a hashtag and then write something, it'll come up as green. A comment will not affect your program in any way in terms of what it tells the robot. A comment is for you. So it's for you to say, what am I doing now and where am I up to in my program? Because, obviously looking at lines of code every single day, it can get quite draining mentally and you can forget where things are. It's very important to set up comments to say, okay, this is part 1 of my program. We don't actually call it part 1, we call it different things. But for now, part 1, this is part 2 of my program, and so on. So comments are really helpful, and you can see comments are green. So if you take off this hashtag point, it'll turn into black. Green, it won't affect anything. So you don't have to worry about, anything here. You can put random gibberish. That will never affect your program. That's why, comments are pretty powerful like that. And they're very helpful. So we're going to be using them as well. So I'm just going to delete a lot of stuff here because I've made some changes. Again, with code, it's very easy. The next thing you need to know is that spaces don't matter. So you can see with this equal sign, if I put a space here, if I don't put a space here, with Python, space or no space, it really doesn't matter. However, it's kind of neat to kind of put spaces in between. Personally, if you don't want to put spaces, you don't have to. That's personal preference. So let's get into the meat of using Python. There are always 2 stages to programming. The first stage is initializing your components, and the second stage is actually using those components to do stuff. With initializing, you need to tell the code, this is where my wheel is, this is the motor it's connected to. This is my the Spike Prime hub, this is what it's doing. These are my sensors, this is the motor. You need to initialize all your components before actually using them. So that's going to be our first step. Now again, I'm going to put a comment here to make sure that it's clear what I'm doing. So initialize components. If you're watching this in America, we use a Z or a Z, you may say, instead of an S, or you can use S, to be honest, doesn't really matter. So initialize components, we've got our first section here, and you can see it's already given us the hub, right? What is the hub? The hub is listing over here, right? So it's the Spike Prime hub, and you can see this fancy command over here. This command is going back to using it, right? So whenever you want to use the Spike Prime hub to do things, instead of writing this word over and over again, we just use the word hub. So again, hub is now used in this little line here. This line will show an image, and if you write happy here, then it'll put a smiley face on your code, on your robot, sorry. So we kind of just set up things like that. However, I'm just going to delete this line because it doesn't really help us do what we want to do. We want to move forward, we want to move back, we want to turn. So now that we've initialized our hub, there is one more thing we need to initialize, and that's our motors. As you can see, if we want to move forward and move back and turn, we want to initialize our motors. So we're going to use motors equals. Now the command to actually use your motors is called motor pair. So motor and then pair. I've got it over here, so that's where I'm reading off. You can just follow me though. A, and then we have comma, E. So what is this command? I'll now explain it. Every time you want to use your motors to either turn forwards or backwards, you would have to write this really long command. Like over here, you may, if you want to go straight, you would put dot, straight, or whatever it is. Instead of using this long command, we just simplify it to motors. You can call this part, this variable, or this component, whatever you want. You can call it, whoops, let me go back. You can call it motor pair if you want to. You can call it underscore motor drivetrain. You can call it just drivetrain. You can call it whatever you want, really. I prefer motors just because it's easy, it's short. Every time we want to use the motors, we're going to call back to this line here, to this variable called motors. Quite simple. Now the next thing you need to know is you need to plug your motors into the correct ports. So I've currently got mine in A and E. So my left wheel is in mode A, my right wheel is in mode B. follow your ports or follow your wires up, or if you've got a frame like mine, just connect your robot and turn, your left, see what number changes in this section here. Turn this one, see what number changes, and you'll figure out what letters your ports are in. That's pretty simple. Make sure you've got yours correct though, because if that's incorrect, then nothing's going to work. So we want to learn how to move forward, how to move backwards, how to move side to side. We don't want to use any sensors yet, so all we need to do is initialize these two things. If you've got this initialized, then you're ready to go. Let's actually talk about moving the robot now. So with moving the robot, this is the second stage of our program. So as I said before, there are two stages, initialization and then the actual movement part. So with our commands to tell the robot what we need to do, we're going to call this execute code. So this stage, execute code, is the second stage. This is where the robot will actually do what we tell it to do. So first things first, let's talk about moving straight. When you're moving straight, there are three things you need to worry about. The first thing is whether you're going straight or not. So the steering should be 0 to go perfectly straight. The second thing is how far you want to go. So you want to go 1,000 degrees, 2,000 degrees, 500 degrees. And then the last thing is the power. So you may want to move at 40% power, at 50% power. These are the three different parameters that you need to worry about when moving straight. And luckily, there's one line that handles all of this for us. And this is the line over here. So motors.move, and then we're going to put brackets, 1,000, comma, degrees, comma. I put a comma space, it's really up to you. Steering equals 0, comma, speed equals 40. Let me just make sure all my spacing is correct. Perfect. Okay, so what is this command? You'll already see I've kind of got the base of what I was talking about. So 1,000 degrees. So what is degrees? Degrees is a measure of rotation, or how far you want to go. So 360 degrees is one full rotation of this wheel. That's it. 1,000 is approximately 2.8 or something like that rotations of this wheel. So it's a straight forward. If you want to move further, change this to 2,000. If you want to move less, change it to maybe 500. So changing this first number will change the amount of degrees. The next thing, steering. If you want to move straight, keep this steering at 0. So in the future, we'll learn how to, later in this video, we'll learn how to go left, how to go right. We're going to actually change the steering, but for now, we're going to go straight, keep the steering at 0. And lastly, speed. This is a percentage. So we normally go at 40 to 50% speed. Normally at 80 to 100, things can get a little bit inaccurate and unreliable. So we keep it low at 40 to 50. However, if you want to experiment, try definitely pedal to the metal. Go ahead, see what 100 looks like, and have some fun. So we're going to keep it at 40 for this video, just for the purpose of education, I guess. And I highly recommend, in competition environments like FLL, keep it at 40 to 50 or 60%. Don't go to 90 or 100. Your robot will become very inaccurate and you won't complete the amount of missions you really want to do. So now that this command is ready, let's see what it looks like. So as you can see, the robot simply moved forward for 500 degrees. With this, if you want to go more forward, make it 1,000. If you want to go less, make it 400. If you don't like the speed, change the speed to 50 to 60. It goes up to 100. And it goes as low as 1, I guess, because 0 is a nothing. Even 1 won't give you much. Normally 10 to 50 to 60 is a pretty good range. And because we're going straight, steering is 0. If you want to move backwards, it's very simple. Just change the speed from 50 to -50. That's what you need to do. Well, I guess we had it at 40. So moving backwards, you just put a negative in front of speed. You can also put a negative in front of degrees, but not in front of both. So don't put -400 degrees and -40 speed, because two negatives cancel out to make a positive. So just put one or the other. I personally prefer speed because we're going to be using that as a parameter to kind of determine to go forwards or backwards a little bit later on for some more advanced stuff. So I prefer speed, but you can also go with steering if you want to. So let's go 500 again. Let's see what 500 degrees backwards looks like. So as you can see, it simply moved back. Simple as that. So we didn't do a lot of work over here, right? Like we simply wrote one line here and a couple lines up here, and that's essentially our program to move forward. Let's say you want to move forwards again. All you have to do, take this whole line, Command or Control C, enter to your 11th line, Command or Control V. And now you've created your second line of code. You can do this over and over. Oops. You can do this over and over and over again. And now, with a simple command like this, you can move forwards and backwards and just copy paste it and change the numbers here. Maybe next time you want to move, 300 backwards or forwards, so change it to a negative. Something else that is really powerful, this line will also make us turn. As I explained before, this steering over here is right now, it's at 0. However, all we need to do to turn is change it. So with turning, we normally, if you want to turn right, it's normally 100 steering. You can also do 90, and it will do it more of like a curved right as opposed to a solid, right like this. So instead of going like that, it'll go kind of like that. But it doesn't really matter. Anywhere from 90 to 100 is really good. If you feel your wheels are dragging a little bit, then definitely change this to a 90. But 100 works pretty well on an FLO map, which has a pretty nice surface. And that's it. Like, that's literally all you need to change to now turn to the right. Just remember that a right turn is 100 and a left turn is negative. Or vice versa if your motors are flipped. It doesn't really matter. Just trial and error to see what you need to do. But once you understand that, this line now does everything you want it to do. It can move forwards if it's gone at 0 and positive. It can move backwards, just put a negative here. If you want to turn right, just put 100 here, and now it's going to do a right turn. If you want to turn left, just put negative 100, and now it's going to do a left turn. The only thing you need to worry about is the degrees and the power. So with a turn, 500 degrees is kind of big. It's kind of like a donut kind of thing. It's just going to do almost a full rotation. Just don't get confused with this. If you put 90 here, it doesn't mean the robot's going to do a 90-degree turn. Because again, remember, the degrees that you're telling into the laptop is essentially the rotation of this wheel over here. So if that's 360, I've turned it 360 degrees, 90 would be a quarter of that, which is just like this. So it'll just do like a little turn like that. So just try 90, see what happens. And if it's not, high enough for a 90-degree turn, change this to 140 or 150, or just increase it. If that's too much, decrease it to 130. It's going to take some tinkering, some fine tuning, but eventually you'll get the right number to turn the perfect degrees you want. So I've got my turn at 140 degrees, which is great. I think that's about a 90-degree turn, but we'll see if that works. I've got my steering at negative 100. So that's a left turn. If I want to go right, positive 100. And I've got my speed at 40, which is a pretty good turning speed. You don't want to go too fast because then it will become a lot more inaccurate. But 40 to 50 is pretty good. So let's see what this looks like. So as you can see, it did a very nice 90-degree turn. If you want to turn to the left, simply put a negative here, as I've said. Let's see what that looks like. So a simple turn the other way. Pretty easy, pretty good to go. Now, if you want to do more than 90 degrees, 90 degree, like more than a right angle turn, just change this 140 to maybe 180, and that will be more. If you want to do 360, we had 140 as, a right angle turn. If you want to do a full revolution, I guess that's 140 times 4, which is 560, I think. You can double check my math, but that will do like a full rotation, like a spin. So, change this number up and down to change the amount of turn you want to do. Also, if you feel like your turn's too slow, too fast, change the speed. This steering, you can normally keep it at negative 100 and 100 for left and for right. So you don't need to worry about, you don't really need to worry about it. And that's about it. That's pretty much this whole video, because now you know how to set up your program, you know how to move forwards, you know how to move backwards, you know how to turn left and right. This is the basic movement element of Spike. And in Python, it's very easy, as you can see. It's one line. You can take this line, copy paste it over and over again. There's no need to write this line over again, like, manually. You can just say, okay, if I want to turn, now I want to go straight, make this 0. Done. That will now go straight. Change the degrees to maybe 1000. So what this program will do is it'll go straight in the second. So the first command is a move turn. As you can see, steering is at negative 100. It'll do a left turn. It'll then move straight. And then this command here, what does it do? You can see steering is at negative 100. It's another left turn. Okay, if you want to go straight after that, take this line, Command or Control C, go enter, Command or Control V. That's it. Now it's going to go straight again. You can create a square, you can create whatever you want with just this basic line, but it looks like we've done a fair amount of work. It's really simple. It's just one line over and over again with different edits and changes to the parameters to make it work. So that's the end of this video. Definitely, if you enjoyed it, continue in the series, right? This is just the start of your programming journey. You'll see that, you know, your straights may not be as straight as you want them to be. They may be a little bit veering to the side. Your turns, if you're running them over and over again, the turns may not be as far as you want them. So in the future, we're going to learn things like, you know, how to use a gyro sensor, how to use a color sensor to maintain your straight lines and to go, you know, perfect turns, that kind of thing. So definitely continue. There should be more videos in this series coming out. And I'll see you guys in the next one.